Hi class, so let's start with the next part of the linear regression with Python. So in this case, we're going to talk about the application of linear regression using Python. And in this, so make sure that in this case, you're going to follow up. You're gonna download this file on your Colab. So you're going to download to your computer and then open it up in your Colab. You're going to follow along with me, and that's what you're going to submit for this assignment, for this prep for machine learning. Also, you're gonna need this file, the CSV file, so we're gonna use that to play around with their data, okay? So make sure that you open up your linear regression, your Colab. You can go into upload notebook, right? Choose your file that you wanna open up, which is the one you just downloaded. And also, you wanna upload your USA housing.csv. So you're gonna click upload, and then you're gonna choose the file that you wanna do. Okay, so you upload that file, and that's what we're gonna use. All right, so in this linear regression, so this mostly is just to code for references. Please watch the video for that we just did for linear regression to understand the concept. Your neighbor, so this is let's give an example. So your neighbor is a real estate agent and wants some help predicting house prices for regions in the USA. It would be great if you could somehow create a model for her that allows her to put the few features of a house and returns back an estimate of what the house would sell for. She has asked you if you could help out with the new data science skills. You say yes, and decided that the linear regression might be a good path to solve this problem. Your neighbor then gives you some information about a bunch of houses in regions in the United States. It is all in the data set. So make sure that you upload the USA housing.csv. The data contains the following columns: the average area income, and this is the average income of the residents of the city house located in, the average house age, the average age house in the same city, the average number of rooms, this is going to be the average number of rooms for houses in the city. Average area number of bedrooms means the average number of bedrooms for houses in the data city. This, in the same city area, population of the city house is located in, the price is the house sold out, and the address of the house. So let's get started. So when you're able to get some of the data from your neighbor for housing prices as the CSV set, let's get the environment ready for the libraries we'll need to import. All right, so what we're gonna do here is we're gonna need a couple of tools. So because we need to make sure that we can play around with our data, we're gonna download pandas to create our data frame. And then we're gonna import NumPy as NP. We're going to import matplotlib, that's correct, .pyplot to be able to this data for our data visualization. We're going to put a plt and then import our Seaborn for more data visualization as SNS. And let's see. There's nothing wrong there. Okay, good. So let's extract the data from our house CSV, right? So in order to be able to create a data frame, we need to extract our data. We need to read this data from our CSV file, right? So what we're gonna do is we're gonna use, let's call it USA housing, and that's gonna be our data frame. So we need to use pandas. And we're gonna read from the CSV file. Okay. Now we need to be able to find the path of the CSV file. So all we can do is just go into the three dots there and click on copy path. So that's the easiest way to make sure that we find that we're actually reading from the file that we want to, extract the information from. And let's make sure that we put this in quotations. And let's make sure it works and didn't give any trouble. Now let's make sure that we have the information that we wanted. Right, it's always good to make sure that your information is there. So let's do the 5. If we don't put, if we use head, it's gonna give us the top 5 data. And there you go, perfect. So again, let's refresh ourselves, right, with this data. So remember that each column is a feature. So here, this is a feature. Average area income is a feature. The average area of the house H is a feature. They're all continuous values, right? The average area number of rooms, that's a feature. Another average area number of bedrooms is a feature. The area population is a feature, and the price is another feature. The address is another feature, right? So now notice that in this case, the address would not make any difference, right? That column doesn't make that. We don't need the address to be able to. The address would not make any. It would not help us make a prediction on the price value of the house. So so we can exclude that. We don't need that data, right? We want to look our label, our target label will be the price because we're trying to predict the price of the house. So we can actually use also USA's housing .info to see if we are missing any data, right? Remember, it is very, very important that our data is clean. What does that mean, clean? It means that every single data, it has a value. There's no nulls. Sorry. As you can see, there's 5,000 entries, right? 5,000 data, and every single column, every single feature has their 5,000 values. And we can actually even see that they all have a float value, a continuous value, right? They're floats, except the address. That's an object, so that will be a category. So just to be able to look more into the information. So you can see that we have a data frame now, right? This is this right here, the housing is a data frame now. So you can see the data frame built in. So remember, a data frame is a combination of multiple series in PAMDAS. PAMDAS provides you with series and data frames, and a data frame is a bunch of series put together. Now let's see. Let's look at more important information about our data. So what we can do, just practice, right? Let's look at the describe method. And the describe method is going to give us a lot of information about each of the feature of the column, the features. So this is going to tell us what the count is, how many data do we have, right? So they all have 5,000. That's good. This is going to do the mean of your average area income, the mean of your average house age, the mean of your area of the average number of rooms, the average area number of your bedrooms, and so on, and then so on. So this is going to be the standard deviation. This is going to be the minimum. It's going to determine which one's the minimum value. This is going to give you the 25% of the area income, and the 50% 75, and the maximum. We can also look at the columns, what are the names of the columns, by doing the USA housing dot columns. So this is a attribute. So how do I know it's an attribute versus a method? Because if it has a parenthesis, that's a method. If it doesn't have a parenthesis, it means it's an attribute. All right. All right. So the next is we're gonna do some exploratory data analysis. Wait, oh, why is this not going down? Okay. So we're gonna analyze our data. We're gonna find it to see if there's any correlation between the data. Right. So what we can do here is let's use the Seaborn and create a pair plot of our USA housing. So what this is going to do is to be able to see if we find any relationship between the data. All right, so we can see how the data is being clustered together. And you can see because on bedroom numbers, it's actually is either one or the other one, right? So you can see that there's a better relationship between the average area income and the price, right? There's a much more linear regression line value there versus the other ones. Like for example, this cluster average area number of rooms, and the average area income. That doesn't have much of a correlation there, right? So this allows us to be able to analyze our data. Let's see other graphs. So let's see how uh, our price value distribute in displays in a graph, right? So let's do the distribution plot and of our USA housing price. So this is gonna give us an understanding of what the price of the value of the house is and the standard deviation, the mean. So just give us a little bit more understanding. Let's see the correlation between the columns. So we can do the seaborne heat map of our USA housing correlation. So you can see the more correlated, the lighter they are, the darker is less correlated. We actually mentioned that the average area income and the area house average was almost no correlation. But we can see that there's a correlation between or a closer correlation between the price and the average area income. So there is some correlation there. So most of them have some sort of correlation with the price, right? If you can see that of course price and price will have a correlation, and average population and average population will have a correlation. That's why they have those light values. But you can see that in some way there is some correlation, right? The most correlated would be the average area income. All right, so we saw some data, we analyzed it. So now let's see how we can actually use linear regression to be able to predict our house. Let's now begin to train our regression model. We'll need to first split our data into an X-ray and an X array that contains the features to train on, and the Y array that has the target variable. In this case, the price column. So this will toss out the address columns because it only has text info, that they're not linear regression model that we can use. So we talked about, right, the house address does not make any difference in our prediction for the price. So what we're going to do here is we're going to try to collect all the data that does not include all the labels that do not have the price nor the address for our X array. And for our Y array, it's just going to contain the price value. So let's do that. So we're going to say X is going to be equal to the USA housing. So we're looking at the data frame, and we're going to specifically look at the average area income. So that's the first one. We're going to do the average area house age. So we're creating a list inside this USA housing to just grab the labels that we want. We're going to do the average area number of rooms. We're going to do the average area number of bedrooms. We're going to do the area of population. So let's see if there's something wrong with this. Okay, there's nothing wrong. We're going to do the Y value as well. So our Y value will be, and notice that I'm actually not making a mistake here. I'm actually putting the X in capital because it's going to represent more than just one column, more than one just feature. So that's why I'm putting it in X as a capital. That's a common practice when representing your X value, your features. And then for the y value, you're going to put in lowercase because it's only going to represent 1. So we're going to have USA housing, and it's going to be the price. So that looks good. So we're separating the data. We're excluding the price and the address from here, from our X arrays, from our data for our X values, right? Our features. And then for the Y, it's just going to be the price. That's going to be our target, our label. And now what we're going to do is we're going to split our training and testing set to be able to train our data. So in order to be able to do that, we need to first extract or import from the sklearn model selection. We're going to import this train test split. Let's make sure this is correct. That is correct. So what we're doing is we're importing this. I want to say it's probably a constructor, probably. Yeah. So actually, no, sorry. It's a method that or function. Sorry, a function that is going to split our data. It's a function, and what we're gonna do here is it's gonna return through 4 different outputs. It's going to output the X string, a set of all the X string data. So a set. So what's gonna do is you're gonna put all this data, and it's going to randomly select a portion of it to be the train data, and then the other one will be the test data. But it also is going to do it for your Y as is going to do it for your X. So it's going to separate your data, your X data and your Y data, to be your train data and your test data. So we're going to have train, test, split, and we're going to pass in our X that we created over here, and we're going to pass our Y. And then we're going to specifically say how much do we want to split our size. So let's do 0.2. So sorry, 0.2. So this is going to be 20% will be test and 80% will be train. Okay. And then we're going to use a random state, and that's so that we can all have the same output in the end. So I'm going to choose 101. And let's make sure that this is running well. All right. So what we're doing here is we're splitting the data. So remember, we have a bunch of data, thousands of lines. And what we're doing is we're saying this set of data will be for the training data, and this will be for the test. So that's what we're doing. Now, because we have 2, right? We have the X and the Y. This is going to do it for both of them. All right. Now what we're going to do is, now that we have split our data, we want to create it and train the model. So from sklearn linear model, we're going to import our linear regression. So we're going to choose linear regression to for our model. So we're going to call it, we're going to create this object right now. It's empty. It's called LM, which will be our linear regression model. We can call it, yeah, let's call it, this is our linear regression model, LM, and linear regression. And so we're creating this linear regression that doesn't have nothing yet. Let's make sure this is running. This is running. And now we're gonna go and we're gonna fit our data. So we're gonna train our data. So we're gonna take our X train and our Y train, and we're gonna train our data. So when we use the fit method on this object LM, we're training our linear regression on this data right here. And let's run it. I think I need to run everything again. I think it just disconnected. Sorry, I think my internet is a little lagging, but hopefully it catches up right now. Let me put pause here. All right, so we didn't have any problems, so that's good. So we are able to train our data, and now let's see. Let's check some of our. Let's see the coefficient. The y-intercept of our model. So if we want to see what the coefficient of our model is, we can just do LM. Remember, this is going to be a linear line, a straight line, so a linear equation. So a linear equation has a y-intercept. So let's figure out what the intercept is. Intercept underscore. So this is an attribute of the object. I think I spelled intercept wrong. Oops. Oh, let's see. Intercept. Intercept. Linear intercept. Did we change it? Hold on. Oh, I don't know for what reason it wasn't working. I just click run before and then run it again and it worked. All right, so just that's to see what the linear regression y-intercept would be. If we want to be able to see the coefficients, we can do coefficient data frame of the pd.data, data frame lm.coef, and then x columns equal to coefficients. So this is what we're doing here. Is we're creating a new data frame called coefficient data frames, and what we're doing is we're going through all the coefficients of your linear regression and using the columns, the names of the columns, and then we're creating we're going to create this new column called coefficients. So we're going to put all this information in the column coefficients. So this is the new coefficient that we're going to have in this new data frame, but we're using this data to be able to pass it in. So this is going to be the data, the coefficients coming from, and then we're going to put this as we're going to use those for our the columns that we're going to extract the information from. And so we run it, and we can see that our data is there. We didn't, let's print it. Coef df. There you go. As you can see, that the data is a little bit off because this is just made up data. But if we want to try something different, we can try. You can try this other data here. Actually, it would be more. Let me put pause here. So if you actually want to try some other set, you can actually use this one instead. This from the California housing. So this is how you would actually extract it. You would have to import this fetch California housing, and then you would have to create this object from the to be able to get the data frame from the fetch California housing, and then you would have to import this fetch open ML, and then you're gonna create you're gonna adjust your data to the home house prices, and use it as a frame, and then you can use the description and see the data what you get. But that's if you want to try out some real data. I want to try this one because it's a little bit easier for me to manipulate. Housing that info. So again, we can double check that everything's there, and then we can say USA housing dot describe. Oh, sorry. Yeah. No, hold on. Oh, sorry. We're doing predictions here. Oops. Let's This is predictions here. So actually we're doing the predictions here. Sorry, I was distracted. Let's grab the predictions out from the test and see how well it does. So we're gonna do predictions using our test data. Okay, so we're gonna see how well does it predict the data, and then let's plot that. Let's plot it in a scatter in a scatter graph. So what we're gonna do is we're gonna compare our prediction with the actual value. So the y test actually contains the actual value, and what we're gonna do is we're gonna compare it with our predictions. We're gonna see how well do they predict it. And you can see that it's actually pretty close, right? There is a very linear correlation between them, so that's a very good prediction. And then what we can do is we can see how the predictions, the test predictions were what's the difference in prediction. So let's see, a distribution plot of the y, sorry, the y test. So that's the actual value and the predictions. We want to see what's the difference, how far are we from each other, and I'm going to graph them. And let's have 50 different blocks. So what this is doing is calculating how far out is the prediction from each other. Maybe we should have done a square or an absolute value there, so that it can be but no, that's fine. That's fine. Now what we're gonna do is we're gonna check how well our performance is. So let's do sklearn. Sorry, from sklearn. We're gonna import metrics to be able to evaluate our performance. So what we're gonna do is we're gonna print our mean absolute value error, comma matrix mean absolute error from the y test and the prediction. So you see how easy it is. You don't have to do any calculations. You don't have to do any mathematical calculation. It will do it for you. So all we have to do is just call in the function that we want to do. So we're calling the matrix, and we're going to do the, instead of the mean value, absolute value error, we're going to do the mean square error. And then for the other one, we're going to do the square root. We're going to do the square root of the matrix mean square error. right? So let's see if that works. Oops, sorry, forgot to put the matrix. I think I made might have done a mistake here. Matrix. Oh, sorry, MP. This is numpy. Square root. There we go. Oh, sorry, this is MSE, and this is the root MSE.